Okay, so the next word we're going to talk about is acceleration. We've already talked about velocity, we've already talked about position and how they're related to each other. It turns out that there's a relationship between acceleration and velocity. First, let's talk about the definition. Acceleration is nothing more than the rate in which velocity changes per unit of time. And when we talk about the word rate, we're typically saying per unit of time. So if I'm talking about acceleration as being the rate in which velocity is changing, I'm talking about how much velocity is changing per unit of time. Typically that unit of time is a second. So when we talk about acceleration, the units of acceleration should be the change in velocity over time, the rate in which velocity is changing with respect to time. Well, that would make the units to be meters per second, because we're talking about the units of velocity, which is a meter per second, So it's typically expressed in several forms. You have this form, meter per second per second. Let me rewrite that so it's a little clearer. Meter per second per second. That's one form in which it's written. Another form is meter per second squared. Okay, but the one that we're going to be using in this class is going to be meter per second, or meter second to the negative 2, which just means meters per second per second. Okay, so that's the units of acceleration. And this is the definition: the change in velocity per unit of time. When we're referring to acceleration, that's what we're referring to. How much is my velocity changing per second? Is it increasing by 1 second or 1 meter per second for every second? So take for an example of a car that has a velocity initially of 10 meters per second. In 1 second, if it's an acceleration of 1 meter per second, that means in 1 second that car is going to be traveling 11 meters per second. In another second it'd be 12, 13, 14, 15, 16, on and on and on and on and on. So when we're referring to acceleration, we're referring to how much that velocity is changing per second. So that means for every second it's going up by 1. Now my acceleration can be negative. As a matter of fact, the most famous acceleration due to gravity, is a negative value. So in the case of a car that's experiencing a negative 1 meter per second, it starts off at 10, that means in 1 second, or it starts at about 10 meters per second, that means in 1 second it's been reduced to 9 meters per second, and then 8, then 7, then 6, then 4, then all the way down to 0, and then it still goes. So it goes to 0 meters per second, then negative 1, negative 2, negative 3, negative 4. Keeps on going. That velocity just turns into a negative velocity. So negative 10 meters per second, negative 11, negative 12, on and on and on and on and on. Okay? So acceleration being the change in velocity per unit of time. That is the definition of acceleration. Now, one thing we want to keep in mind is that we can have a positive acceleration and still be slowing down. Slowing down, speeding up is referring to speed. So if we talk about acceleration, we talk about velocity, we're once again talking about vectors, and the direction of those vectors with respect to each other will tell me whether my speed is increasing or decreasing. Remember, speed doesn't have direction, but velocity does. So if we talk about the velocity of an object, let's say an object is moving in this direction with a velocity of 10 meters per second. Okay? If the acceleration is in the same direction of 1 meter seconds to the negative 2, okay? If it's in the same direction, then the velocity, this is for t equals 0, at 1 second later, then the velocity is now increased to 11 meters per second, with the acceleration still staying the same. Let me draw my arrows. Here's my velocity, here's my acceleration. So actually my velocity would be something like that. And then for every second it would be keep going up and up and up and up. Now if this acceleration wasn't just 1 meter per second, instead it was a negative 1 meters per second, okay, so then we're talking the velocity for that 1 second later is equal to 10, oh not 10, after 1 second is equal to 9. So a smaller arrow. Okay, and in this case, sorry about that, the acceleration is pointing in this direction. Okay. Now, if you wanted to look at it graphically, one thing that you should see is that for the first second, and I'm going to erase everything, for the first second I have a velocity of 10 meters per second. So the length of this arrow is representing 10 meters per second. So that length is representing 10 meters per second. Now if I'm experiencing a negative 1 meter per second acceleration, then after 1 second this arrow is actually going to reduce by a value of 1. Okay? So this is the new velocity. That new velocity is going to be 9 meters per second. This red arrow, which is barely visible, let me see if I can darken it up a little bit. This red arrow represents the change in velocity. That's how much my velocity has changed. Okay? That's the change in velocity. So that little red arrow over here is the change in velocity. So the change in velocity, the size of this arrow, divided by this 1 second, is going to give me my acceleration. Now if it was a more drastic acceleration, let's say that this was not reduced to 5 or to 9 meters per second, but let's say it's reduced to 6 meters per second. Okay? So in 1 second it goes from 10 meters per second to 6 meters per second. Then the graphical representation is that we get a change in velocity that looks something like this. So that's the change in the velocity right there. Okay? That change in velocity divided by the amount of time it experiences that change in velocity, in this case once again 1 second, is my acceleration. Okay? So how much this is changing per second is the acceleration of this object. Now I can see the arrow is pointing this way, so that means it's a negative acceleration. It's pointing in the opposite direction. Remember that when we talk about a coordinate system, this way is a negative value, this way is a positive value. So this is a negative acceleration. Now if we were experiencing a positive acceleration, so let's say once again we got something traveling at 10 meters per second, and then at some time later it's up to 14 meters per second after 1 second. Then we can say that this, from here to here, from here to here, is the change in my velocity. That's how much my velocity has increased in 1 second. So right there is the change in velocity. Okay? So that little red arrow there is the change in velocity. That's an increase of 4 in 1 second. So the acceleration would be 4 from this value right here, meters per second per second. Okay? That's acceleration in a nutshell. That's how it breaks down. It's the change in velocity per unit of second. Okay, one thing you've got to be very careful about, and it's a very common mistake, and I don't know really why, is that people tend to confuse acceleration with velocity. Velocity is the change in your position. It's how far you travel basically in a given second. Okay? The acceleration is different. It's how much, if you're traveling on a long straight road, it's how much your speedometer is changing per second. Is it going up by 4 notches in a second, or is it going up by 1 notch per second, or is it going down by 10 notches in a second? That's the difference between acceleration and velocity. They're not the same thing. They're two completely different things. Okay? So acceleration is the rate in which velocity is changing, or the change in velocity per unit of time. Again, the exact same thing. Not the definition of velocity, which is the change in which is displacement divided by time, or the change in position divided by time. Two separate things. Okay? It is a vector. It does have a direction associated with that, so you got to keep that in mind too. It can be a negative value. Alright, that's acceleration. I'm going to talk about a specific kind of acceleration next.